A very good afternoon, all my dear students. In this lecture, we will see the property of Laplace transform, that is multiplication by t raised to the power n, where n is a positive integer. The statement of this property is let Laplace of f of t is equals to f of s then Laplace of t raised to the power n into f of t is equals to minus 1 to the power n into nth derivative with respect to s of f of s. This is equation 1. Now the proof of this property is we have given here the definition, that is Laplace of f of t equals to f of s. Laplace of f of t equals to f of s means Laplace of f of t equals to, by the definition, integration from 0 to infinity e to the power minus st into f of t dt. This is the definition for t greater than or equals to 0 for this interval. So we prove this property by mathematical induction. We prove this by mathematical induction. We have given here, that is let Laplace of f of t is equals to f of s. This is given. This implies that by using the definition, that is integration from 0 to infinity e to the power minus st into f of t dt. This is the definition of Laplace transform, that is equals to f of s. Now differentiate this equation with respect to s. We get what we get. So dds of integration 0 to infinity e to the power minus st into f of t dt, that is equals to dds of f of s. Now, by Leibniz rule, what is Leibniz rule? That is differentiation of integration. Leibniz rule of differentiation under integration. What he says that this differentiation goes under the integration sign and that will become partial derivative. So integration 0 to infinity del del s of e to the power minus st into f of t dt, that is equals to dds of f of s. So differentiate this term with respect to s. What we get? This implies that integration 0 to infinity, this is minus t, this power derivative of this power term is minus st का derivative with respect to s के साथ minus t into exponential term e to the power minus st f of t dt, that is equals to dds of f of s. So multiply by minus sign on both sides. What we get? This implies that This is integration from 0 to infinity. This is e to the power minus st into t into f of t into f of t dt, that is equals to minus 1 of dds of f of s. And this implies that Laplace of, apply the definition of Laplace transform here, left hand side, what we get? Laplace of this is t into f of t, that is equals to minus 1 into dds of f of s. So from this equation we say that this is suppose equation number 2. From equation 2 we say that this equation 1 is true for, therefore equation 1 is true for n is equals to 1. If we put here n equals to 1 in equation 1, you will get minus 1 into derivative with respect to s of f of s. It means that equation 1 is true for n is equals to 1. Now, let us consider equation 1 is true for n. If it is true for n, then what we say that Laplace of, from equation 1, Laplace of t raised to power n into f of t, that is equals to minus 1 to the power n into derivative with respect to s of f of s. So we have to consider here the equation 1 is true for n equals to n. So we may write this equation as, we have to prove here this equation 1 is true for n equals to n plus 1, means this is valid for n plus 1. So we have to differentiate this equation with respect to s. We have, before differentiating we have to apply here the definition, that is, this implies that integration 0 to infinity e to the power minus st into t raised to power n into f of t dt, that is equals to minus 1 to the power n into nth derivative with respect to s of f of s. So differentiate this equation with respect to s. We have so dds of integration 0 to infinity e to the power minus st t raised to power n into f of t dt, that is equals to minus 1 to the power n into nth derivative with respect to s of f of s. So this implies that again by Leibniz theorem, this derivative goes under integration sign. It will becomes partial derivative, that is del del s of e to the power minus st into t raised to power n f of t dt, that is equals to minus 1 to the power n into nth derivative with respect to s of f of s. So differentiate with respect to s. This is integration 0 to infinity minus t into e to the power minus st t raised to power n f of t dt minus 1 to the power n nth derivative with respect to s of f of s. So this implies that multiply by minus sign, you will get 0 to infinity e to the power minus st. This is t into t raised to power n, that is t to the power n plus 1 f of t dt, that is equals to minus 1 to the power n into minus 1 to the power n plus 1 into n plus 1th derivative with respect to s of f of s. So by apply the definition of Laplace transform here, this is nothing but Laplace of t raised to power n plus 1 into f of t, that is equals to minus 1 to the power n plus 1 into n plus 1th derivative with respect to s of f of s. So in this way, we have to prove the result for n equals to n plus 1. Hence the result is true for n plus 1 if it is true for n. So by mathematical induction, therefore, by mathematical induction, Laplace of t raised to the power n into f of t is equals to minus 1 to the power n into nth derivative with respect to s of f of s, where n is equals to 2, 3 up to so on. So it is valid for all values of n. So in this way, we have to prove the result. We prove here the result, that is multiplication by t raised to power n. This property is proved here. Now we will see one of the example. Of multiplication by t raised to power n. Find the Laplace transform of t square into sine 80. The solution of this example is, now we have Laplace of t square into sine 80. This is equals to, now apply the multiplication by t raised to power n property, that is minus 1 to the power 2 into second derivative with respect to s of Laplace of sine 80, and this is equals to minus 1 square means plus second derivative with respect to s. Laplace of sine 80 is a upon s square plus a square. Now differentiate this term first time, that is radius of minus a upon s square plus a square into derivative of this term, that is twice s. So this is minus 2a, take outside the differentiation, this is minus twice a. Again differentiate this term, that is s upon s square plus a square. What we get? This is s square plus a square into derivative of s is 1 minus s into derivative of into derivative of this term. This is its square. So s into derivative of this term 2 times s square plus a square into derivative of this term is twice s divided by this is s square plus a square to the power 4. So take s square plus a square common and cancel with denominator. What we get? This is equals to minus 2a in bracket s square plus a square. This is minus 2s into 2s minus 4s square divided by s square plus a square its cube. So this s square, this get cancelled, means minus 3s square, s square minus 4s square, that is minus 3s square. If we multiply by minus sign, what we get? This is 2a into 3s square minus a square divided by s divided by this is s square plus a square its cube. This is the Laplace transform of t square into sin 80. So in this lecture we have seen the multiplication by t raised to the power n property of Laplace transform, and one example on that Laplace transform, that is Laplace of t square into sin 80, that we have find out here. So friends, we will stop here. Thank you.